So welcome guys, welcome to my second lecture. Okay, so in this lecture I will discuss about the topic reaction in solution. Okay, so introduction. So before that I will give two example. Okay, that two reactions occurring in two phase. So first reaction is the decomposition of nitrogen pentoxide. Okay, here is the reaction. This is the first order reaction actually. Okay, and the table shows it is taken from the book KG Ledler. Okay, so here we can see the three parameters are given here: K, A and E. K is the rate constant, A is the frequency factor, and E is the activation energy. Okay, so the reaction actually occurs in the gas phase, right? So first of all, what happens actually, here we can see that the values of K almost same here, right? And same is also for the A here is in the log scale, and E also same here. So next again we'll take another example of ethyl iodide and triethylamine reaction. This is an adduct reaction and of the second order. Okay, this reaction occurs in the liquid phase. Okay, and here K, A and E. So for K we can see that the K increases drastically, whereas A also increases from 4 to 4.9. 4.9 means almost 10 to the power 4.9 means 10 to the power 5, almost 10 times increases, whereas E decreases. Now the question is that when the reaction occurs in liquid, so there is certain factors like surface tension, viscosity, dielectric constant, those things actually affect the reaction rate. But whereas in gas phase reaction there is no such kind of effect which will vary the reaction rate. Okay, so that's why here no such interaction, that's why no such effect on the reaction rate, because the solvent molecule will not react with solid molecule here, but here the solvent molecules also react with the solid molecules. That's why there is a change in Ka and E. Okay, so we can see that here they interact, and this interaction is electrostatically. Why? Because here we can see that as we go down the hexane to toluene to benzene to nitrobenzene, the polarity of the medium increases. Polarity means dipole moment increases, that is dielectric constant increases. So as this dipole moment or polarity increases, there is the electrostatic interaction also increases between that solute and solvent molecules. So we can say that the main culprit is that electrostatic interaction. Okay, so these electrostatic interactions play a key role for this changing in the Ka and E. Okay, next topic is reaction between ions. So when reaction occurring in liquid phase, how the reaction takes place, like between two ions, right? So there is a number of models. Theoretical kineticists, okay, the kineticians who deals with the theory, so they gave a number of models. Among them some are the difficult and some are easy, so we'll take the easiest model. Okay, so one is that double sphere method. Okay, so how is that one? So actually in this case what happens, two ions, okay, we are not discussing first about the charges. Okay, two ions, they approaches from infinity, okay, and initially, and after that according to the activated complex at the final state they collide with each other. Okay, so here what happens, so they just approaches each other. You can't say that they collide or not, so they just touch each other. Okay, here, and this is the double sphere. The ions are compared as the hard spheres, and the solvent is compared as the continuous dielectric. So from here we can calculate the free energy of work. Okay, a free energy contribution. So first see, when the ions at a distance x apart, the force acting between them, that will be Z charges by distance square, okay, and epsilon constant. So this is nothing. So next is that dw work done equals to minus force into displacement. So why is that negative? Because the distance between them, this distance actually decreases as the ions approaches. Okay, so this one. Now for getting the w, we have to integrate this one. So by integrating this one from infinity to dab, the diameter, the summation of the radius, okay, we will get this one, this W. This is work actually for getting two approaches of this two ion. This work is equal to the free energy change involved in the process of moving ions up to one another. So this will be the electrostatic contribution, right? So there will be the non-electrostatic contribution also. So this free energy actually nothing but the electrostatic contribution towards the gives free energy. So as well there will be non-electrostatic contribution. So total free energy is given as summation of electrostatic, electrostatic plus non-electrostatic, and it is per mole, that's why it is divided by n. Now we will put this value, this one, okay, here. So we will get this one, and again from the theory of absolute reaction rate we know K is equals to this one, Kt by H into e to the power minus delta G hash by RT. So from equation 3 and 4, these two equation, by comparing these two equation or by putting the value of this delta G hash here, we can write this equation. Just by putting this value here we will get this equation. So this is this equation actually, this is actually wrong. So we'll go to a next slide. So in this slide actually what happens, we'll take the natural log. By taking natural log we'll get this one. This derivation actually also given in the ladler. I took this derivation from the ladler. You can go there also. By taking the ln we will get this kind of equation, and finally we will reach here. Okay, so here k naught is equals to this one, this whole thing, okay, and this one. So what is that k naught? So if e means epsilon is dielectric constant is infinite, then k equals to k naught. That means at infinite dilution the rate constant of the reaction is nothing but k naught. So next is that our main equation of interest is this one, ln k is equals to ln k naught minus zp square by this one. This is an important topic for your CSR as well as GATE exam. Questions can directly come from this equation. So first we will draw a graph between ln k versus 1 by epsilon. We can see this is a straight line, okay, having the slope, negative slope, and with a positive intercept. So intercept is equals to ln k naught. Okay, so we can see that as the, if we go this side epsilon decreases, and if we go this side epsilon increases. So suppose we are going towards this side with increasing in epsilon dielectric constant ln k, that means the epsilon also increases, because as the k is proportional to direct ln k, that means as the ln k increases k also increases. So as dielectric constant increases, reaction rate also increases here. Yeah, and yes, the slope is this one, the mod values. Actually slope is negative here. The value of slope is z as zb square by dab into kt. So next is that we will calculate the entropy of activation. So how? We know that this one, as earlier we derived this equation, this one. Okay, next again we know that delta S, as we know that dg is equals to what, vdp minus s dt, right? From here we can get the s equals to this one. Okay, here it is. So S equals to minus delta G by delta T at constant pressure. So if I put the delta S hash electrostatic contribution, that is free energy of activation, here also the free energy change will be here, delta G hash. So this will, now I will put this delta G value directly here and I will get this one. Okay, see, because all the terms are constant here, n z z b d a b, only the epsilon is the function of temperature, that's why I have to write this way. Now suppose take an example of aqueous solution. So for aqueous solution, epsilon is equals to 80 and this value is this one. This is a fairly experimental value, okay, so overly fair wide t range, right? And let DAB equals to this centimeter. So we will get the delta S hash equals to minus 10 or minus something 9 point something into Z S ZP, this one actually. Okay, so the value of entropy actually depends on the charges of the ion. Suppose there approaches two ions, so the charges of two ion decide what will be the value of delta S or entropy of activation, whether it will decrease or increase. So from here it is clear that if the ZA and ZB are of same charges, so that will delta S dash will be negative. Same charges mean either positive or negative, both will be positive or both will be negative, or and otherwise delta S dash equals to positive, that means they are all of opposite charges. Now take an example, the reactions between CrH26 plus plus, this coordination compound, and CNS minus. So experimental A and delta S dash, and this is the estimated. Okay, this is theoretical and this is experimental. So for experimental theoretical, we can see that it is 10 to the power 19 and 30, so and almost they are equal here. So we will go to the next example. Next example is that this is an reaction between anion, so they are opposite of their of same charges. So in this case the theoretical value is 10 to the power 11 and 10 to the minus 10. So here, so as we can see that if charges are same, so charges if same, then delta S will decreases. So obviously here it is minus 12, it decreases from this value minus 10, and this value, this also A also decreases. And here the next example is that reaction between one uh, negatively charged and one neutral molecule. So here the estimated values is obviously 0 for delta S dash, and for the A frequency factor 10 to the power 13. So here it is actually increases, right? Because suppose one is negative neutral and one another is negative, so negative and positive, that delta S value will increases, and the experimental A is this one. So we are not actually explaining the A value here, right? Only delta S. So this is the case. So you can see there are lots of example in the book also. So I took only 3 example, but the main thing is that why, because this is from mathematics. So from maths we can see if they are same charges, delta S energy of activation decreases. If they are opposite charges, so that will increases. But the main reason is that if suppose they are the same charges, so then in activated complex there will be what happens. So surrounding there some molecules are there, right? Solvent molecules. So when the same charges approaches, what happens, there will be increase in the charges. So they will bind to the surrounding solvent molecule, or there will be more electrostatic interaction between these positive charges or negative charges, whatever may be, with the surrounding solvent molecule. So surrounding solvent molecules will be one kind, you can say like they are bind, so their randomness or movement will what, some kind restricted, right? So they will not move as they earlier their movement was. So this is called the electrostatic restriction. So due to this electrostatic restriction, the solvent molecules entropy or entropy of the solvent molecules will decreases here as compared to here. That's why here entropy, overall entropy, the solvent molecules and solid molecules overall entropy decreases. But here suppose here you come, what happens, one is positive and another is negative. So when here they will neutralize each another, right? So suppose it is plus 5 minus 2, so plus 5 minus 2 is overall charge will be what, plus 3. Now there is the charges decrease in the charges, and this less charges will, there will be less electrostatic interaction between solid and solid molecules, and the entropy decreaseness will be less as compared to here earlier, right? So here entropy will increases in this case, because here the electrostatic restriction is less than initially, but here electrostatic is interaction electro restriction or electro restriction is more than initially. Okay, and next is that was single sphere, and another is that suppose earlier was the double sphere, and another is model is there, that is called the single sphere. So in this case what happens, two ions approaches each other, and after approaching they make one single sphere, this kind of picture, right? So for this one I am not deriving the equation, the final equation actually this one, ln k equals to ln k naught minus this one. If you want you can remember, otherwise not, forget, just remember this one, double sphere. Okay, and actually this is double sphere is the special case of this one. So you can, if you remember this one and just putting this one, we will get this one. That means when r, here it is the r hash, so if you put r hash equals to r hash equals to r equals to rb, then equation 1 transforms equation 2. That means double sphere is a special case of the single sphere model. Okay, so for today's class up to this. Okay, so in the next class I will discuss about those salt effect, right? So like and subscribe our channel. Thank you.